this video, we will begin practical outlier detection using Python. We will start with visual tools like Boxplots, histograms, and scatter plots, and then apply the IQR statistical method to extract the actual outlier value from a dataset. Uh, First, we import the necessary libraries and the dataset. We begin by using a boxplot to visualize the distribution of a single feature. In this case, the cholesterol feature. The boxplot will show us the quantiles Q1, as you can see, Q2 is a median, and Q3. Uh, any data point above Q3 plus 1.5 IQR or below Q1 minus 1.5 IQR can be considered an outlier. This is a powerful way to visually detect potential outliers in the dataset. So, as you can see, we have two below one below than Q1 minus 1.5 IQR that can be considered the outlier, and more than 10 or 15 more than Q3 plus 1.5 IQR that they can also can be considered as an outlier. Using df.columns, we define it to loop all features. Using this definition gives us the names of all the columns in the dataset. And then instead of drawing a box plot manually for each feature, we use a loop. In this loop, I acts as an index representing each feature name one by one. For each I, we call Seaborn's box plot on dfi, which automatically generates a box plot for that feature. Finally, we call plt from matplotlib to display the plot. This way, we efficiently create box plots for all features without writing repetitive code. Next, we visualize the distribution of numeric features using this plot with KDE. This gives a smooth estimate of the distribution, which is helpful to understand the shape of the data. There are many ways to visualize data. Let's look at histogram. A histogram shows the frequency of values in intervals. Below, we plot a histogram of the cholesterol feature with 30 binds. What does 30 binds mean? It means we split the entire range of cholesterol values into 30 equal parts, like 30 buckets. Then we count how many values fall into each part. This gives us a sense of how the values are distributed. Are they mostly low or high, or spread out evenly? Then I used to see the relationship between two numeric features. Here we compare cholesterol vs age by using a scatter plot. Then IQR calculation. Now I manually calculate the IQR to detect the outliers. I firstly find Q1 and Q3, then compute the IQR and define upper and lower bounds. Any value beyond this bounds is marked as an outlier. For Q1 and Q3, we check each data in the cholesterol to do the quantile method. In U, if data is higher than Q3 plus 1.5 IQR, put it on upper. And in L, if lower than Q1 minus 1.5 IQR, put it on lower or L. Then with property lock, we cut the data for features on cholesterol, which has upper and lower cholesterol. In the result, as we can see, we have a 70 upper outlier and two lower outlier. Then outlier IQR outlier to apply the IQR method programmatically and repeatedly. We define a function IQR underline outliers as we can call any name that takes a column and returns its outliers. We call the input A. Then we say come to the column of A, do the quantile method for Q1 and Q3. After this, we calculate IQR. For lower and upper tail, we speak in previous part. So then we do a for loop for each I in A. If I goes out of upper or lower, we append I to the out. Here is in the top. So here my A is cholesterol, as you can see, and we can choose any other column's name instead of cholesterol. Now, if I run the code, in results you can see outliers and their numbers. So at the end, filtering inliers. With the IQR bounds, we can also filter and keep only the data inside the acceptable range, non-outliers. So as you can see, we have 578 row with 14 column. So it means we don't have outliers and just we have the inside of the quartile 1 and 3. In the next video, I will show you how to detect the outliers using statistical methods. See you there.